Welcome back, everyone. This is our last section for Chapter 10, which means tomorrow is your quiz day. Make sure you're in Math Lab getting those homework assignments done. I think they were supposed to be due by midnight tonight, but I think I pushed the date out an extra day to give you some more time. So make sure you're getting those done. Remember, you can still work on them after the due date. You're just going to lose 5% per day if they're late. So try to get in there and make sure you're working on those, okay? So this last section is still surface area and volume, so that's good news, and really just one surface area problem. Remember, surface area, we're just going to try to look at the surfaces individually, look at like the net of what we're trying to do, whereas for the volume we have some formulas that we can rely on. All right, so we're looking at some applications, word problems. That means not always the most fun thing to do, right? But we're going to try to work through some of these. I tried to make these problems parallel to what you're going to be seeing in your homework assignment, so hopefully this will be good reference for you, okay? So let's work through some of these. No steps, just make sure you're reading the problems carefully, trying to understand what it's giving you and what it's asking for. And I think this is going to tie in some of the conversions that we were using in Chapter 9. All right, so let's look at this first one. We have Kevin painting 3 bedrooms in his house. Each bedroom is a 10-foot by 12-foot rectangle, and the rooms have 9-foot ceilings. If a gallon of paint costs $30 and covers about 400 square feet, how much will Kevin need to spend on paint? All right, so he's painting 3 rooms in the house. Now it says that the bedroom is a 10-foot by 12-foot rectangle. Now that's the floor, right? And a 9-foot ceiling. So we're looking at these rooms as rectangular prisms. So let's try to sketch this out. I don't know if you are really good at drawing 3-dimensional figures, but one approach here to make a rectangular prism is to start with a rectangle, and then in a little bit offset from that one, draw the same size of rectangle, or similar. Try to make it similar in size. Just draw the 2 rectangles offset, and then connect their corners. And you're going to have yourself a pretty good looking rectangular prism. Okay, nice little sketch. And so we have a bedroom that's 10 foot by 12 foot. So we have maybe 12 feet. Oops, I need to turn my drawing tool off. And now my eraser, good grief. Okay, so 12 feet, and then 10 feet here, and the 9-foot ceilings means these walls go up 9 feet this way, okay? Now when he goes to paint the room, what surfaces is he actually painting, right? We're clearly going to be using surface area here. We're not going to be filling the room with paint. We're going to be painting the walls with paint, the surfaces, and not the floor and not the ceiling. So we're going to be painting the sides here. We have 2 sides. So we've got 2 side walls. And what are the dimensions of the side walls? Well, they're 9 by 10. So we have 2 9 by 10 walls. Well, 2 times 90 is 180 square feet for those 2 side walls. And then we have the front and the back. Let's change colors. The front and the back, right? 2 side walls. Let's call these the front and back. They're the same also. We have 2 of those. And these ones are 12 by 9 again. So 2 9 by 12, or 12 by 9. 9 times 12 is 108. And if we multiply that by 2, that's 216 square feet. Let me just make sure I don't screw anything up. I do a lot of silly things sometimes in these notes. You guys are catching my little errors, and actually a lot of time it's put stuff in the calculator. So 2 times 9 times 10 was 180, and then 2 times 9 times 12 is 216. Okay, so all together for one room, 180 and 216 is 396 square feet. Okay, that's one room. And it says here that 1 gallon of paint covers 400 square feet. So 1 gallon of paint is going to be good for one room. Well, if he's got 3 rooms, so times 3 rooms, here, let's do this. he's gonna need a gallon. Oh my goodness. So there's gonna be 1 gallon needed for that. Times 3 rooms means he needs 3 gallons. And each of the gallons costs, let's see, if a gallon of paint costs 30 bucks, 3 gallons times $30 each is a total of $90 on paint. Move this over here. $90 for paint. Now that is cutting it a little bit close. I think if this was my house that I was painting, I'd probably, I don't know, buy an extra pint or something for touch-up for later. And I like to go a little heavy on the paint, just my preference, so maybe a 4th gallon even, but at least 90 bucks for paint here. Okay, not so bad. All right, number 2. The Jones family's putting in a rectangular pool in their backyard, and to accommodate the pool, they have to dig a hole that's 30 feet long, 20 feet wide, and 8 feet deep. A company charges $12 for every truckload of dirt removed, and the truck holds 20 cubic yards of dirt. How much will the Jones family have to spend removing dirt? Okay, so this is another rectangular prism. Let's try to draw this out. So they're trying to dig a rectangular space for their pool to go in. Why did I do that again? I'm so sorry. So we're going to draw a rectangle. Try to draw another rectangle about the same size, just offset a little bit, and then connect those corners. And you're going to have a pretty decent looking rectangular prism. And this one is 30 feet long, 20 feet wide, and 8 feet deep. Okay, so these are the dimensions here. This time they're digging a hole. So imagine they're trying to fit this rectangular prism in the ground, and we're going to be trying to figure out how much dirt they're taking out, how much dirt filled that hole before, right? So instead of surface area here, we're looking for how much dirt is in the space. That would be the volume. So the total volume here, volume for a rectangular prism is length times width times height. So the total volume here would be 30 times 20 times 8, which makes the volume, again, let's not make any silly mistakes. 30 times 20 times 8 is 4,800. So we have 4,800 feet cubed of dirt coming out of this rectangular space. Now, the company charges $12 for every truckload of dirt, and the truckload of dirt holds 20 cubic yards. So the truck holds 20 cubic yards. All right, so 20 cubic yards of dirt. This is how much dirt we have, 48 cubic feet of dirt. We got to figure out how many truckloads that is. So we have to know 48 cubic feet is how many cubic yards. So that's going to be our next step here. 48 feet cubed is how many yards cubed, cubic yards. We have to make a conversion here so we can figure out how many truckloads of dirt they're going to be hauling away. So 4,800 feet cubed. Feet cubed means feet times feet times feet, right? So when I make this conversion, I got to get rid of feet 3 times. Now you remember how many feet are in a yard? It's 3 feet in 1 yard. So if I use that unit fraction once, then it gets 1 of the feet to go away and gives me 1 of the yards that I need. So I have to do that again. I know 1 yard is 3 feet, and second time makes the second feet go away, and then the third time, 1 yard, 3 feet, makes the third one go away. And now I have yards times yards times yards. I have yards cubed. So now, again, I'm going to move this because I'm running out of space. We have to multiply straight across the top, multiply straight across the bottom. So 48 times 1 times 1 times 1, or 4,800, is going to be 4,800 yards cubed divided by 3 times 3 is 9 times 3 is 27 on the bottom. And let's get a, wow, let's get a decimal for that. 4,800. Boom, boom, boom. Divided by 3 times 3 times 3, just so I don't screw that up, is 177, let's just say 0.8. 177.8 yards cubed. So we have 177.8 cubic yards of dirt, and each truckload is going to take 20 of those. So let's see, let me go over here. If I have 177.8 yards cubed divided by 20 yards cubed per load, and then I have, let's see, take this 177.8 and divide it by 20, and I have about 8.9 truckloads. Now, can you really make 8.9 truckloads? Nope, which means they're gonna have to make 9 truckloads. And it says that each of them costs $12. So times 12 bucks a pop. Times $12 each means they're going to be spending $108 for dirt removal. Imagine that, having to pay someone to take dirt. Okay, so not hard work in the problem, but definitely a lot of work. But the one that you're going to see in your homework will mirror this. So, you know, if you have good notes to follow, you're just going to basically be changing numbers in the one you're going to work on. Okay, hopefully that makes sense. Let's look at the next one. I think this one is a little easier than the last one. It says a new air conditioning unit, typo, can cool 10,000 cubic feet of space. And is it adequate for a 1,200 square foot home with 10-foot ceilings? So a 1,200 square foot home, that square footage is surface area of the floor, right? This air conditioning unit is cooling all of the space inside, so it's cooling 10,000 cubic feet, that's volume. And this 1,200 square feet, right, that's surface area. But the 1,200 square feet floor space multiplied by the 10-foot ceilings, right? Imagine, I know that the home is not going to be a square, but imagine that, let me just draw another rectangular prism. Okay. You're gonna get good at drawing these. That one actually not so great. But imagine, I know the house isn't a perfect rectangle, but you have 1,200 square feet, so maybe you have, I don't know, 120 here, and then 10 here, whatever. Then you have your 1,200 square feet here, and now you have 10-foot ceilings. So if we want to find the volume, we just have to take that square feet and multiply by the third dimension, which was the 10-foot ceiling. Okay, so we're going to take the 1,200 square feet squared, and multiply by the 10-foot ceilings to give us 12,000 feet cubed of space, okay, of volume. Now the air conditioning unit is, it can cool down 10,000 cubic feet of space. So is that unit going to be adequate for the 1,200 square foot house? I mean, if you want to not have AC in one of your rooms, maybe, but I would say no, right? It can only, nope, let's see, the house is 2,000 cubic feet over its capacity. Okay, hopefully that one is a little easier. Okay, so here's another fun one. A farmer's building a cylindrical tank to store chicken feed. cylindrical tank, so the cylinder is sort of like a Coke can shape there. The tank is going to have an 8-foot diameter and it's going to be 2 feet deep. So draw this out. So to draw a cylinder, we are going to draw sort of like an oval, and then let's make the sides come down, and then make the bottom. That's not going to work because I'm on my drawing tool. Let's make the bottom kind of curve, so it's going to look something like this. Now we have an 8-foot diameter. An 8-foot diameter means that the radius is going to be 4 feet. And if it's 2 feet deep, that means the height. Let's make this more readable. So we have a 4-foot radius. And if it's 2 feet deep, that means the height here is going to be 2 feet. Okay? So it says 1 cubic foot of chicken feed is about 3 pounds. And chicken feed is purchased in 10-pound bags for $8. How much is it going to cost to fill the tank with chicken feed? So if we're trying to fill the tank, we're not covering surface area, right? We're trying to fill up all the space inside the tank. Let's figure out what the volume of that tank is. So volume for a cylinder is pi times radius squared times height. So in this case, 3.14 times the radius of 4 squared times a height of 2. So we're looking at 3.14 times 4 squared times 2. That's 100.48 feet cubed of space there. And it says that 1 cubic foot is about 3 pounds. So if we have 100 cubic feet and we multiply by 3, right? For every one, there's 3 pounds. Multiply by 3 pounds per cubic foot. We're looking at, let's see, multiply by 3, 301.44 pounds of chicken feed. Okay, that's how many pounds are going to go into that cylindrical tank. Now, the chicken feed is sold in 10-pound bags, so how many we're going to be able to buy to fit in that tank? So if we take the 301.44 and divide it by pounds, divided by 10-pound bags, that was a 301, really sloppy. 301. If we take all that and divide it by 10, hopefully we knew that that was going to move the decimal. We had 30.144 bags. So 30.144 bags, obviously you're not going to buy 0.144 of a bag, and 31 bags wouldn't fit. You're going to have it spilling over. So let's just say we can fit about 30 bags, okay? So we can fit 30 bags times, they are $8 each. And 30 times 8 means it's going to cost about $240 to fill the tank with chicken feed. Okay, so it's just sort of one step at a time. I don't know if I can explain the logic in the steps, but hopefully it's making sense. And like I said before, the one you're going to see in your assignment is a lot like this one. I think it's like filling a cylindrical tank of water instead of chicken feed, but same process, so you're really just going to be changing numbers, okay? All right, one last one here. We have a solid ancient square pyramid built with a 900-foot base length and a 500-foot height. If each brick in the construction occupied 2 cubic yards of space, how many bricks were needed to build this square pyramid? So square pyramid's a little harder to draw. We're going to start by making a parallelogram. And it's not pretty, but try to draw yourself a parallelogram. And then just label a point up here in space and connect the corners to that point. And you're going to have a decent looking square pyramid. Okay, so a square pyramid means that the base is a square, and it says the base length is 900. So this is 900 feet by 900 feet. And then it says that the height, so the height would be this distance in here, is going to be 500 feet. And we're looking at a solid pyramid, and we're trying to figure out how many bricks it took to fill up that whole solid pyramid. So again, this is going to be a volume. Volume for a pyramid is length times width times height divided by 3. So in this case, 900 times 900 times 500 divided by 3. That's going to be a big number. Let's see. 900 times 900 times 500, all divided by 3. That's 135 million. 135 million, and those were feet, so cubic feet. Okay, now it says that each brick in the construction occupied 2 cubic yards. So we're going to have to make another conversion here from feet cubed to yards cubed. So we have 135 million. That's 6 zeros. It was 6 zeros, right? Yeah. Feet cubed. So feet, feet, feet. Okay. We have to get rid of yards again. I mean, get rid of feet again. And same thing, 3 feet, 1 yard, trying to get to yards. It's really the exact same thing we did before. So 3 feet in a yard, and 3 feet in 1 yard. And that makes the feet, 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 feet cancel, and leaves us with the yards that we're trying to get to. So this is going to give us, multiply straight across the top, still 135 million. And the bottom, 3 times 3 is 9 times 3 is 27, but this is going to be yards cubed. So let's take this and divide all of that by 27, and that gives me 5 million. Right? Just making sure. Let's do it again. 135, 1, 2, 3, 4, 5, 6, divided by 3 times 3 times 3. Yep, 5 million. Okay, so 5 million yards cubed. So that's the total volume. It was 135 million feet cubed, but that's 5 million yards cubed. Now it says that each brick occupied 2 cubic yards. So each brick the volume for each brick is 2 yards cubed. So we're going to take the 5 million total yards cubed and see how many bricks fit into that. Divide it by 2 yards cubed per brick. And if we divide 5 by 2, we're going to get 2.5. I just want to make sure. It's going to be 2,500,000. And that's bricks. That's a lot of bricks. Okay, so 2,500,000 bricks to fill up that solid ancient square pyramid. Okay, again, you're going to see one with a similar setup, just maybe some different language. Actually, it might even be a pyramid there, just some different numbers. So I know these are slightly complicated. Just follow along. These are parallel to what you're going to see in your assignments. And most likely when I set up your quiz for tomorrow, I will not put one of these applications on there. If I do, it would probably be an easy one like this air conditioning unit problem. Okay, just a little heads up on that. But that wraps up our geometry unit. So quiz tomorrow, and then on Wednesday we'll begin our final unit, and then hopefully by the